Hi, so today's topic is adding, subtracting, and multiplying polynomials. So what are polynomials? Well, polynomials are expressions consisting of variables, and variables are letters that represent unknown numerical values. So here's a list of polynomials. Again, they are polynomials because they have letters in them, right? The letters are variables. Okay, now we're going to start with adding polynomials. So the first step to adding polynomials is to find the like terms. What are like terms? So here's an example of like terms. So like terms, are terms that have the same variable, so in this case x, and the same exponent, so in this case 2. Okay. A bad example of a like term, which are also unlike terms, is as shown here, x squared and 3x to the 4th power. Why are they unlike terms? Well, that's because they have different exponents on the variable. Okay? Like terms must have the same variable and the same exponent on that variable. If the variable is different, they are not like terms. If the exponents on the variable are different, then they are not like terms. Okay. So after finding the like terms, we have to add them up, right? In the case of adding polynomials. Okay. If the terms are different, meaning they are unlike terms, we cannot combine them. We cannot touch them. Okay, we can only add up, we can only combine the like terms. Okay. So here we're going to do an example, which is 5x squared plus 46x plus x squared plus 10 plus x. Okay. So from here, we can see that 5x squared and x squared are like terms. Why? Because they have the same variable x and the same exponent, which is 2. Okay, now we're going to circle them. Now we also see another set of like terms, which is 46x and x. Why are they like terms? Because they both have the same variable x and the same exponent. What is that exponent? I don't see anything on top of the x. Well, that's because there's an imaginary 1. Why is there an imaginary 1? Because anything to the 1 power is itself. So x to the 1 power is still x, which is why we don't write the imaginary 1 exponent here. Okay, so we're going to circle 46x and x. Now 10, there's no like terms for 10, so we're just going to leave 10 alone. Now we're going to go to the second step. We're going to add up only the like terms. So we're going to add 5x squared and x squared. Okay, so how do we do that? Well, first, we need to just bring down, this x squared. So we're going to leave the variable and the variable's exponents alone. We're going to only add the number in front of that variable, which in this case happens to be 5, and another imaginary 1 here, right? Because anything times 1 is also itself. Okay, so we're going to add 5 and this imaginary 1, which happens to give us 6. And bringing down the x squared, we get 6x squared. Okay. Now we're going to try 46x plus x. Right, combining them, 46 plus this imaginary 1 is 47. And we're going to bring down this x, which we get 47x. Now we're going to just bring down the 10. Okay. Now we're going to combine all the answers together. How do we do that? We're going to put pluses here. Why do we put plus symbols there? Well, that's because each of these numbers are positive. And initially, there's positive numbers. There's a plus sign here and a plus sign here. Okay, and a plus sign here. So we're going to bring down the plus sign to get the final answer of 6x squared plus 47x plus 10. Okay, now we're going to try 2 more examples. So for this example, we have 9z squared plus 8x plus 5z squared plus z plus 5zx. In this example, we can see that there's only one set of like terms, which happens to be 9z squared and 5z squared. Why? Because for these terms, they have the same variable and the same exponent on that variable. Now, because the other terms, are not like terms, therefore we leave them alone, and we're only going to add 9z squared and 5z squared. Okay? So how do we do that? We're going to bring down the z squared, and we're only going to add the number in front of that variable, which happens to be 9 and 5. And 9 plus 5 is 14, and bringing down the z squared, we get 14z squared. And we're going to leave the unlike terms alone, so we're going to just bring them down. Now for the final answer, we're just going to put plus symbols in front of them because there were plus symbols in the top. So we're going to bring the plus symbols downwards to get the final answer of 14z squared plus 8x plus z plus 5zx. Okay, now we're going to try this last example for adding polynomials. Okay, so remember the first step is to combine the like terms, which we can see with 5x squared and x squared. Why? Because they both have the same variable x and the same exponent on top of that variable 2. Now we're going to find to see if there are other like terms. Well, we see that 4z and z are like terms. Why? Because they have the same variable z and the same exponent on that variable, the imaginary 1. Okay, now that's all the like terms that we have for this example. So then we're going to go to the next step, which is to combine them. So we're going to add 5x squared and x squared. Okay, remember there's an imaginary 1 here. So 5 plus 1 is 6, and we're going to leave the x squared alone, so we're going to bring it down. So you get 6x squared. Now we're going to try 4z and z. Remember there's an imaginary 1 here, so 4 plus 1 is 5, and bringing down the z, we get 5z. Okay, and we're going to just bring the unlike term down, which is 21, bring it down. Now to get the final answer, we're going to just put plus symbols in front of them because there are plus symbols on the top, so we're going to just bring them down. So we get 6x squared plus 5z plus 21, which is the final answer for the simplified form. Okay, now we're going to try subtracting polynomials. So this is similar to adding polynomials, meaning that the first step is to find the like terms, right? Then we're going to organize the like terms together. Then finally, we're going to subtract only the like terms. Only the like terms. We don't touch unlike terms. Okay, we don't combine them. Okay, now here's an example, which is 5x squared minus 46x minus x squared minus 10 minus x. Remember the first step to find the like terms, which happens to be 5x squared and negative x squared. Okay, in this case, the symbol is very important. Negative x squared. Now the next set of like terms is 46x, which is negative, okay, and x, which is also negative. Now we're going to combine the like terms. Okay, so we're going to start with 5x squared and x squared. Now for them, okay, we're going to say it's going to be 5x squared minus x squared. So we're going to leave the exponents and the variable alone, and we're only going to deal with the number in front of that that variable, which happens to be 5 and 1. And what's 5 minus 1? It's 4. And we're bringing down the x squared, we get 4x squared. So we're going to write it back up here. Okay, 4x squared. Okay, now we're going to try negative 46x minus x. So we're going to combine that. Okay, now negative 46x minus x. We have to do one extra step, which is to keep this sign, change this sign, and change this sign. Okay, remember, we learned before we had to do KCC or KFC, right? Keep, change, or keep, flip, change, which means to keep this symbol and to change the other two symbols, right? To change the other two signs. So to do that, we get 46x plus negative x. Okay, now combining this negative 46 and this negative 1 here, right? This imaginary 1, we get negative 47x. Okay, so we're going to bring that up here, negative 47x. Now we're going to bring this negative 10, which is an unlike term, downwards. And now we're going to combine them. Now this is different from adding polynomials. Why? Because we're going to keep the sign here. So this sign is negative. We're going to make it a minus sign. This sign is also negative. We're going to make it a minus sign. To get the final answer of 4x squared minus 47x minus 10. Okay, so that's the final answer of this simplified polynomial. Now we're going to try 2 more examples of subtracting polynomials. So this example is 6j to the third minus 9x minus 5j to the third plus z squared plus 70. Remember the first step is to find the like terms, which happens to be only one set, which is 6j to the third and 5j to the third, which is negative. Okay, because that is the only like term, we're going to proceed to combining the like terms. Okay, which happens to be j to the third. Why? Because we leave the variable and the exponents of the variable alone, so which is j to the third, And we're going to subtract only the number in front of that variable, which happens to be 6 and 5. And 6 minus 5 is just 1, right? We can write a 1 here or just keep it alone because any variable by itself has an imaginary 1 in front of it. Now we're going to bring down the other unlike terms down, which happens to be negative 9x, z squared, which is positive, but it's covered by the circle, and then positive 70. Now we're going to combine them. How do we combine them? We're going to make this negative into a minus sign, and because the other variables, the other terms are positive, we're going to put a plus sign between them. Okay, to get the final answer of j to the third minus 9x plus, because it's positive z squared, plus z squared, and plus, because 70 is positive, plus 70. Okay, so now the second example is 13x squared minus 71z minus x squared plus 21 plus zx plus 3z. Okay, remember the first step is to find the like terms, where the first set is 13x squared and negative x squared. Why? Because they have the same variable and the same exponent on that variable. Now let's see if there are other like terms. Okay, so there's another set of like terms, which happens to be negative 71z and positive 3z. Now 21 and zx are unlike terms, so we're going to leave that alone. So we're going to proceed to the next step, which is to combine them. So we're going to combine 13x squared and negative x squared first. Okay, so we're going to do a little math here. So it's going to be 13x squared minus x squared. Remember, we keep the x squared alone, and we're only going to touch the number in front of that variable, which happens to be 13 and 1. So 13 minus 1 is 12, and keeping the x squared, we get 12x squared. So we're going to bring that up here, 12x squared. Okay, now we're going to proceed to combining negative 71z and positive 3z. Okay, so we're going to write negative 71z and 3z. Well, remember when we add unlike signs, right? So here's the negative and here's the positive. We're going to just do normal subtraction, which is going to be 71 minus 3. Okay, as shown here, 71 minus 3, which is 68. Okay, now we're going to see what is the symbol that we put, what sign do we put on the 68? It's going to be the sign of the largest absolute value. So the absolute value of negative 71 is 71. The absolute value of 3 is 3. Because 71 is bigger and 71 has a negative sign, the answer for this question, okay, will be negative. Okay, so 71 minus 3 is 68, and keeping this negative sign, we get negative 68z. Remember, don't forget the sign. Okay, now we're going to bring this negative 68z to the top, which is here, and we're going to bring the unlike terms to the side, so plus positive 21 and positive zx. Now we're going to put everything together, right? We're going to just put plus symbols everywhere. Okay, so we get the final answer of 12x squared plus negative 68z plus 21 plus zx. Now we can also simplify this to 12x squared minus 68z plus 21 plus zx. Okay, now we're going to proceed to multiply polynomials. To multiply polynomials, we need to do the distribution property. So the distribution property says that you need to distribute each term with each other, okay, each other is on the other side, if they are in separate parentheses. Okay, so now we're going to proceed to multiplying polynomials. So for multiplying polynomials, we need to remember the distribution property, which states that you need to distribute each term with each other if they are in separate parentheses. Okay, so this will be clear when we go through with an example. Now, a tip is to work with two groups at a time, because sometimes there might be questions where you have to multiply 3 sets of polynomials, right? So 3 sets meaning that they're in 3 different parentheses. So working 2 at a time will be a lot easier than working with 3 all at once. Okay, and then after you do the distribution property, you're going to combine the like terms. So here's an example. Okay, so it's a set of x plus 1 times the other set x plus 3. So the first step is to distribute each term with each other. So we're going to start with x times x. Okay, how do we do x times x? Well, when we're multiplying variables, okay, we're going to keep the variables together. Okay, so we don't put any signs, we don't put a plus or a minus between the variables when we multiply for the final answer. Then we're going to add the exponents of that variable, which in this case happens to be an imaginary 1 here and imaginary 1 here. So keeping this variable, which is x, and adding the exponent, which is 1 plus 1, which is 2, we get this product as x squared. So again, how do we get x squared? When we multiply variables, we keep the variable alone, which is x, and we're going to add the exponent of that variable, which is 1, imaginary 1 here, and imaginary 1 here. 1 plus 1 is 2. Okay, now we're going to distribute this x to this 3. Okay, which is x times 3. How do we do x times 3? Well, you can't do anything. You can only combine them together by putting the number in front and the variable at the end. So we get 3x, right, which is the same thing as 3 times x. Okay, now we're going to distribute this 1 to the other sets of other sets of terms in the other parenthesis. So we're going to do 1 times x. Okay, same thing. We can't do anything, so we can only put the 1 in front and a variable at the end, which happens to be 1x, but because 1x is the same thing as x, I'm going to erase the imaginary 1. Okay, Now we're going to distribute 1 and 3. Okay, 1 times 3 is normal math. 1 times 3 is just 3. Now we're going to see if there are like terms. If there are, then we have to combine them. So we see that this x and this 3x are like terms because they have the same variable with the same exponent on that variable. Now we're going to combine everything, okay, with the sign that the term has. So this is a positive 3x, so we're going to put a plus here. This is a positive x, so we're going to put a plus here. This is a positive 3, so we're going to put plus here. To get the final answer of x squared plus 3x plus x plus 3. Okay, now, but this is not the most simplified answer. So we're going to combine them, okay, to get x squared plus 4x plus 3. Where did we get this 4x? We know that these are like terms, so we add the number in front of the same variable, which is 3 and 1, to get 4x. Okay, so we're going to do one last example, which is negative 2 times x plus 0.5 times 2x squared minus 3. So we're going to do, we can start with any order, so I'm going to decide to do these two parentheses first, then we're going to do this group. Remember, a hint is to do 2 groups at a time, so this group and this group. Okay, so I'm going to distribute x times 2x squared. Okay, x times 2x squared. How do we do that? We're going to first multiply the number in front of that variable, which happens to be 1 times 2, which is 2. Then we're going to keep the variable alone, which is x. And then we're going to multiply the exponent of that variable, which happens to be 1 plus 2, which is 3. So we get the final answer of 2x3. Then we'll distribute x to negative 3, which is x times negative 3. We can't do anything, so we're going to bring the number negative 3 in the front and x at the end to get negative 3x. Then we're going to do 0.5, distribute to 2x squared, right? We're just going to multiply the numbers. So 0.5 times 2 is 1, and keeping x squared, we get x squared. Now we're going to do another distribution, which is 0.5 times negative 3, okay, which is normal math. You get negative 1.5. Now this is the same thing as a previous question, except now we add to distribute this negative 2. Okay, so we combined everything together from here. Now we have to bring down this negative 2. Now we're going to distribute this negative 2 to each one of these terms in the parentheses. To get the answer, right, negative 2 times 2x to 3. We're just going to multiply the numbers together, the numbers only. So negative 2 times 2 is negative 4, leaving the variable and the exponent of the variable alone. Now we're going to distribute this negative 2 to this negative 3x. Right, negative 2 times negative 3 is positive 6. Okay, this is very important. Like terms, right, negative times negative equals a positive. A positive times a positive equals a positive. Unlike signs multiplied together gives you a negative. So a positive times a negative gives you a negative. This we must remember. So negative 2 times negative 3, because they have the same sign, right, negative, you get an answer of positive 6. Okay, we're going to just bring down the variable. Now we're going to distribute this negative 2 times x squared. Okay, we can't do anything, so we're going to just put the negative 2 in the front and then x squared at the end. Now one last distribution, which is negative 2 times negative 1.5, okay, which is normal math, 3. Now remember, because it's negative and negative, the product has to be positive. Okay, so this is the final simplified version of this polynomial. Okay. Now we're going to do one last question, which is very similar to your practice questions. Okay, so for this question, it's saying that a equals 3x squared plus 5x minus 6, and b equals negative 2x squared minus 6x plus 7. If it is so, then a minus b equals what? So first we have to remember what PEMDAS is. Okay, so this is a refresher of what PEMDAS is. Okay, so we're going to do this. So a, this is a, minus, okay, minus b, b. Okay, now this is a very tricky question. Why? Because we have to distribute this negative sign. Okay, this is very important. Why? Because this is similar to negative 1, right, imaginary 1 here, times this thing. Okay, so we're going to distribute that negative 1 to each of these terms for the other set of parentheses, which is negative 1 times negative 2x squared, right? Negative 1 times negative 2 is positive 2, leaving the exponent of the variable and the variable alone. Now negative 1 times negative 6, right? We get a positive 6 because like signs gives you positive signs as a product. Now we're going to leave the variable alone. Now negative 1 times positive 7 gives you negative 7 because unlike terms, if you add them, unlike signs multiply together, gives you a negative sign. Okay, now I'm going to erase the parenthesis here. Okay, to get here. Now we're going to find the like terms. Okay, so we have one here, we have another set here, and another set here. And the next step is to combine the like terms. Okay, 3x squared plus 2x squared gives you 5x squared. Now combining 5x and 6x, we get 11x. Now combining negative 6 and negative 7, we have to do a little bit of math at the side. Negative 6 minus 7. We have to do keep, change. So negative 6 stays the same. Change the sign of this minus sign, which is plus, and change the sign of 7, which is negative 7. Negative 6 plus negative 7, right, gives you the negative 13. Okay, so we're going to write this negative 13 here. Now we're going to combine everything. Okay, how do we combine that? We're going to keep the sign of the term. So this is a positive 11x, so we're going to put a plus here. This is negative 13, we're going to just put a big minus here. To get the final answer of 5x squared plus 11x minus 13, which is the answer choice 2. Okay. Now good luck on your practice problems. Be careful with your calculations and make sure to check over your work.